All right, here we go. 0.001 molar. What is the pH? I'll take my calculator. 0.0001 log negative. pH is 4. Duh. But and you can look at this one, see one, because that's 1 times 10 to the negative 4th. But this one you can't do in your head. So what is the molarity of that? Well, find the pH. Well, this is first, we're going to touch this number in. 3.234 EE 6 negative. And then we're going to hit log negative. And we see 5.49. I'm going to call this 5.5. So the pOH is 5.5. That means that the pH is 9.5 because these two numbers have to equal 14. See, this was giving you the OH. This one gave you the H. What is the P? This is for honors. 0.325 grams, 0.325 for 1 times 1 over 36.4. Honors people, you know what I'm doing. 0.325 divided by 36.4 equals 0.0089 moles. 0.0089 moles. 0.089 moles in 1.5 liters of water is how many moles per 1 liter? So I'm going to say divided by 1.5. That's going to give me this number. And now I want to know the pH. The molarity is 0.0059. 0.0059. And now to find the pH, I just hit log negative. The pH is 2.2. All right, great. From the scale, what do we got? All right, got AB. Shampoo. Shampoo is going to be a base, but it's not going to be the strongest base. So I'm going to say that that is letter C. Toilet hospital cleaner. Toilet cleaner, that's going to be a strong base. I will give that F. Water, bruh. That's neutral. That's a B. Strong acid. Well, that's going to be way over here. Orange or lemon. That's going to be pretty strong. All right. The hydronium producers. That's all of these. That's letter E. The hydroxide producer. That's all of these. That's letter D. Give the pH of the following substances. Again, this is easy. 0.000002 log negative. That's a pH of 5.7. And see, it's giving you the H. All right? Right here, the pOH of 4, well, then the pH equals 10 because they both together have to equal 14. All right? Cool, cool. Water, pH is 7 if it's neutral. All right, great. Label the following. Soap, base. Metal cleaner, acid, anything that reacts with metals. Dawn, that's the soap. Sundrop flavoring, that's citric acid. Tastes fruity. Texas Peach, also an acid. All right, this is only for my honors peeps. First, we got to balance this bad boy. Let's see. Going to need a 2 there. And that gives me 2 4 oxygens. So 2 there. I believe that's it. 1, 2, 1, 2. Adding this will cause a shift to the right. And the KQ would say the same. No change. Removing water, it's a liquid. See, look, I made sure you knew it was a liquid. So nothing would happen and nothing would happen. Because remember, liquids and solids don't affect this. Adding pressure means more pressure means less gas bubbles. There's only one gas bubble on the right. So it's going to shift to the right. KEQ, not going to change. Pressure doesn't change it. Concentration doesn't change it. Only temperature. Removing heat. All right, now this, you know, is the combustion process, so it produces heat. So removing heat would actually make it go better. Making it colder would actually make it go more to the right. And the KEQ would increase because you would have more products. More products, the KEQ goes up. More reactants, the KEQ goes down. Write the pH of the following solutions. Label each as acid, base, or neutral, all right? 0.0034, 0.0034 log negative, pH of 2.5 or 2.46 pH, and that's an acid, duh, it's below 7. 0.1, 2, 3, 4, 5, 7, 8, all right? 0.000078 log negative gives me 5.1, but that is a pOH of 5.1, which means that the pH is like around is 8.9. So this is a base, because 5.1, 8.9, 14. That's neutral, duh, it's to the negative 7th. And this is to the negative 9th, but it's the base. Now that's tricky. The base is to the negative 9th, so it means the pH is 5, so it's actually an acid, okay? Two characteristics of acids. They react with metals, and they taste spicy or fruity. Great job. Bases feel slickery, taste bitter, are cleaners. What is the most dangerous result of nuclear decay? Gamma rays. Describe a beta negative part. 0 to negative 1b. It's an electron, mass 0, charge negative 1. What is the smallest type of material which can stop a beta particle? Aluminum foil or wood, something like that. Honors, you may not have seen that note. You can look it up in the notes. But aluminum foil. Alpha particle, 4 over 2, each E++. Its mass is 4. It's got 2 protons. It's like, describe it, it's like the helium nucleus. An isotope has a half-life of 30 years. If 1 gram disintegrates over 90 years, how many grams of cesium-137 would remain? Let me read this again. I'm sorry, I was listening to things in the background. An isotope of cesium-137 has a half-life of 30 years. If 1 gram disappears over 90 years, how many grams of I think this is written wrong. If over 30 years, 1 gram disintegrated or disappeared, it means 0.33 grams would disappear every 10. It means this one's written wrong. I'm sorry, y'all. Here we go. That one's just written poorly. Actinium-226 has a half-life of 29 hours. If 100 milligrams disintegrates over 58 hours, how many milligrams will remain? Hundred milligrams. So we start out with 100. It's just written funny. And 58 hours go by. That's 2 of these 29-hour half-lives. So 50, 25. 25 grams will remain. Okay? And then, honors, you didn't have to do these, and that's it. Let me go back, see if my brain's not working. Has a half-life of 30 years. If 1 gram disintegrates over 90 years, how many grams would remain? Okay. I just misread this. It means we start with 1 gram. Every half-life is 30 years. 90 years goes by. So we're going to divide by 2 3 times. My brain is fried, y'all. 0.5, 0.25, 0.125 grams remains. I'm sorry. This was just worded a little funky. My brain is broken. Peace out, y'all.